Okay, welcome to Group 19's three topic proposal. Today, I'm going to be going through a series of projects. The first one is a Freshness First FPGA packet router. And this is really point of this project is to build a small FPGA networking demo on the Altera DE0CV FPGA. And the idea is that instead of processing packets only in the order that they arrive, that the system will check if they're still fresh. And it's not meant to really implement a full Ethernet stack per se, but really to have a hardware demo that shows through RTL that shows packet parsing, comparison, routing logic, and visible debug output on the LEDs or 7-segment display. I want to really explore how real-time systems care about newest updates rather than old queued data, and FPGA is a really good way to see this with predictable low latency. Moving on to optimizing matrix multiplication mapping. This is my second idea, and I want to work. This is really an optimizer that works on the mapping of hardware, specifically in the context of AI accelerators. Uh, you know, as we know, AI inference uses matrix multiplication quite often, and I would like to model a simplified optimizer that models these accelerators and chooses tile sizes and mapping strategies that reduce memory traffic. I think it fits within ECE and also explores optimization in a pretty interesting way. That's why I want to do this project. Moving on to my third and final idea, and that's also relating to the first one, kind of. I want to work on the formal verification of a first in, first out FIFO buffer on the same Altera FPGA. And this is really just to explore really the field of formal verification in a deeper, more succinct way. And even though FIFOs are simple in concept, there's a lot of small bugs, control that come from the control logic, overflow, underflow, lost data, or data coming out in the wrong order. And I would want to design a parameterized synchronous FIFO in System Verilog that could do this. And I would want to use a formal verification tool that could either prove these properties or return a counterexample. And this would really, give me valuable experience when it comes to formal verification and FIFOs, also a very common thing in FPGA pipelines, interfaces, and hardware modules. Thank you so much, and I appreciate you guys taking the time. Let me know if you have any questions.